Sure. So we'll look at the questions on this 2015. 2015. This is exactly from the question paper. As you can see there, you have the Department of Education, November 2015. Good. Now, in question 8, at a certain school, there are 64 boys in grade 10. Their sport preference are indicated as below. So 64 boys, that's the total we're looking at. Now, 24 of the boys play soccer. You have 28 playing rugby, and then 10 of them play both rugby and soccer. And then you have 22 that do not participate on either, right? So the first question is to represent the Venn diagram, of course, right? So I know that I'm gonna have the box. There's my box there. And then I'm gonna have an event, right? So for me to sketch the second event, I need to check for something. I need to check if there's an intersection. We have 10 players that both play rugby. So we'll say rugby. And then we have soccer, right? I know there's an intersection because of there's soccer and rugby. Here it's going to be soccer and rugby. Now, I know that's the start, right? I'm going to start with the 10. Right? Start with this 10. 10 boys. 10 boys do rugby and soccer. Then we have 24 that play soccer. So now, because of these 10 that play soccer and rugby, they're also included in the 24. So in this 24, you have also the ones that play soccer and rugby. So in total here, there has to be 24, right? So it means I'm short with 14 for me to get the, sorry, not on soccer, on rugby, on soccer. I need 14 because in total, 24 boys play soccer. Within the 24, there are 10 that plays both soccer and rugby. And then I get to the ones that play rugby. So it's 28. 28 kids play rugby. So with the 28, I already have the 10. So I'm short with 18. So in total, if I extract this thing here, right? Let us say I extract it. This is my arc. If it's extracted, I have this 10, then I have the 18. In total, when I add these, they give me 28, right? And then with soccer, you have 10 already, and then you were short with 14. So it means in total, you have this 24. Okay, good. Now, we're gonna look at the last one. In the last one, they say the 22 boys do not participate, right? The 22 is going to be outside the events, right? They do not play soccer or rugby, right? So let me just explain something here on the Venn diagram, right? So if I have damn. Okay, there we go. If I have a Venn diagram like this, right? So I'm gonna have my events, and I have my events. Now, let us say this is A and then this is B. Right now, you have the sample. Now, if I'm looking at A, right? The number of A, right? This is A, this is the whole of A. Right? It's including, that's the whole of A. Now, if I want this part here, the intersection, you see this part here, this part is A and B. That's that part, A and B. And then this whole thing here, right? This one they in blue. All of that inside this, all of that inside. It's A or B, right? That is A or B. That's whatever that's inside here, all of it. Now going back to my question, right? Getting back here. They're saying calculate the probability that a Britain boy at school selected at random plays soccer and rugby. Soccer and rugby. RNS. There's RNS. So 8.1.28, we're gonna say probability that Elena plays both rugby and soccer. It's equal to the number of the boys that play rugby and soccer all over the total sample. The total sample. So what do I mean when I say total sample? The total sample is the 64 here, right? That's the total sample. So it's 10 all over 64. There we go. And then you have 8 B. Calculate the probability that the learner, no, the boy plays soccer. Okay. So this is the probability of R O S. So it's everything that is inside the, right? R O S. So it's going to be equal to the number of everything in the events, right? All over the total sample. So I know the sample was 64, right? So when I add 18, 10, and 14, it's going to give me 82. And there's my answer there. And then the last question, are the events a grade 10 boy plays soccer at the school and a grade 10 boy plays rugby at the school mutually exclusive? Justify your answer. Okay, now let us define the term. Let's look deeper into the term. So I have different sets of Venn diagrams, right? Can I have a Venn diagram? Two events. A versus A versus B. Okay, I'm gonna have number one, and let's have number two. A, B, and that's number two there. So let's say you have 4, then you have 3 here, you have 2. So you have 7, and then you have 2, then you have 5. Right, let's have number 3. Uh, 7, 3. Then A, B. Okay, and then number 4. 7, 2, 9, 8. A, B. This is number 4. Good. Now, when we look at something, there's a difference between these two sets of these 4 Venn diagrams. If I look at the first one, there is nothing outside A or B, right? There's nothing outside A or B. There's nothing outside. There's nothing on the sample. Everything is within the events, right? So these are inclusive, right? They're exclusive, sorry. Exclusive online AVR exclusive. Who is this thing now? Before I write among, they are inclusive. Inclusive. Yes, they're inclusive because of there's an intersection there. And they are also one. exhaustive, 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 exhaustive. Exhaustive means there's nothing outside here, right? That's exhaustive. If I look at this, they're not exhaustive. If I look at this, these are exhaustive too. Exhaustive. Everything is inside the events. Like it's completely inside the events. There's nothing outside the events. Intersection, right? Inclusive is the intersection, right? Intersection, intersection. There's an intersection. Here, they are exclusive. These ones are exclusive. Exclusive. This is not my strongest point, you know. Exclusive. Yeah. Exclusive. So there's no intersection. There is no A and B. It's equal to zero. Right? There's no intersection. It's exclusive. Here it's inclusive because there's A and B. It's not exhaustive because there's 5 outside. We're good. And then we have, so these ones we say mutually exclusive, no intersection, right? Here also mutually exclusive, mutually exclusive. They are mutually exclusive because there's no intersection. A and B is equal to 0. It does not exist. And it's exhaustive. So events that are exhaustive, number 2, and mutually exclusive, we say that these are special events. These are special. These ones here, these ones are special. Very special. 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 They are called complementary events. They are very special. Okay, now continuing to this thing here. These ones are inclusive, right? And not exhaustive. So the mutually exclusive, you can see, if you can see something, mutually exclusive, it means intersection, right? Here again, mutually exclusive, no A and B. So if I go back to this thing here, mutually exclusive, do you see that there's an intersection? There's A and B, there's R and S, there's an intersection here. There's an intersection. So I'm going to say, are they mutually exclusive? No. Why? Because of R and S. It's not equal to 0.